Hello everyone and welcome back to Arctic Retro, and today I am gonna build something. It's been a while since I built something. The previous videos were all exploration of different computers, but now I want to build something. And today I'm gonna test out the 4K filming and see if that makes it any better on YouTube. Okay, this is the thing I want to build, and it is the RGB2HDMI adapter that makes it possible to connect the HDMI to an Amiga 500 in this case. And I have the parts necessary here. This is some kind of kit, and also I have a Raspberry Pi Zero. I am a little bit concerned about building this because it uses very tiny SMD components, surface mounted stuff like small resistors and very small ICs. So we'll see. I think I will need some magnification, and yeah, what I'm concerned about is the soldering, of course. So the RGB2HDMI device has become very popular, and it uses a Raspberry Pi Zero, which is the smallest one because that fits better inside the machine. So the Raspberry Pi does the conversion from the RGB signal to HDMI, and it does a very good job at that. However, I had a hard time finding a Raspberry Pi Zero because there's a shortage of electronic components worldwide, and these are sold out everywhere. So I was lucky to find two actually at a local seller here in Norway. Alright, let's see what's in the bag. There's a whole bunch of small components, not a whole bunch, some. These are some capacitors and resistors, and then there's this little PCB which has a socket in, but the socket is not soldered in. It's just placed in into the PCB. So that's the little PCB. Let's zoom in. Speaking of PCBs, if you need produced any PCBs like this, you can actually go to my sponsor PCBWay.com. PCBWay produces very good quality PCBs at affordable prices. Besides that, they also do services like CNC machining, 3D printing, PCB assembly and advanced PCB. If you are in the need of an already made PCB design, go visit their shared project sites where you can find a lot of high quality PCB designs. Check out PCBWay.com. This little PCB looks rather nice. The challenge, however, is to solder on these chips. I think I will manage the other components like the resistor and SMD capacitor, but the three chips here, I'm pretty nervous about how to solder them. Hopefully it will work out okay, and if not, then I will call this video a failure and you will see that shame. Hopefully not. Before I continue, I'm actually gonna test this Raspberry Pi and see if it actually works. There's no use in continuing it if it's not working. And on this little micro SD card, I have a Raspberry Pi boot image that is actually a special kind of a Linux image that runs on this microcomputer, and yeah, it's really amazing that this little board is actually a whole computer capable of running a desktop, a Linux desktop with a keyboard and HDMI output, and yeah, all sorts of interfaces, I/O interface and USB, keyboard, mouse, yeah, you name it. You can connect a camera here. So that's really amazing. All right, so this actually uses HDMI mini contact. So I got a little adapter here, and this is a regular HDMI cable. I haven't yet gotten hold of an internal HDMI cable that I can mount into the Amiga, those kind of flat flex cables. So I have to use just a regular HDMI cable for now. And then we connect the power to the power input USB like that. Then I'm gonna turn it on and we'll see the output on the TV. And this is not the actual software for the RGB2HDMI converter, but this is a regular regular Raspberry Pi boot image. All right, so it seems to be working. You have the Raspberry Pi logo here, and now it's booting into Pixel. Obviously, I haven't connected any mouse or keyboard or anything on this one, so can't do much. But here you can see at least the desktop and the start menu running on that tiny little computer. Okay, I think I'm ready to start soldering, but before that I'm gonna clean this PCB to remove any possible problems with contamination of the solder pads. Just to explain how this RGB to HDMI device actually works, the thing is we take this PCB and add some pin headers to it, and then we take out the tiniest chip and put this PCB in its place in the socket. And then there's a socket on top of this PCB where we put the tiniest chip. Finally, we have this connector here where we're supposed to put the Raspberry Pi Zero. So in order for this to work, you have to solder in the things in the correct order. For example, you can't start with this socket because then it will be very hard to solder in the surface mount components underneath. Also, it will be hard to solder in the pin headers that comes up from behind. So I guess I'll start with the little SMD components on top, which are here. Okay, I'm gonna dive straight into it, and I'm gonna start with these smaller components here, and I'm gonna wait with chips, take them last, because it's better to practice on these other components that can actually maybe be fixed if I do a mistake. So I actually got two types of solder paste, both from China, from eBay. This one, I have used that before, it was okay, and then I have this one in this tube. I have squirted some of this one onto this paper, and the plan now is to spread the solder paste thinly onto the solder pads, and then stick the component on top. Maybe add a little additional flux, and then use heated air, my air gun, to heat up the component so that the solder melts and drags its way into the solder pads. At least that's the plan, but how it will turn out we will see now. So I'm a little bit anxious about this, but I think it will be okay. I'm gonna start with this little chip here, U4. Try not to bend the legs. And this one goes here. Alright, so if I'm gonna be able to work on this, I need to move the camera a little bit away. It will be in an angle then, but I hope that's okay. Well, let's see now if I take a little bit of the solder paste and smear it onto the pads. It doesn't stick very well, and that's a problem actually, but yeah, I'm just gonna scrape it off and move it over to the pads. That's way too much. I use this little cotton swab just to press it down. So the hope is that the surface tension of the flux within the solder paste will drag the chip over to the pads. So I think the position there is good. Just add a little bit of extra liquid flux. So now I'm heating up my cheap yeah, hot air gun with the smallest tip. Let's see if that's enough to melt it. Okay, here we go. So I think I had a too low temperature. Let me try again. Starting to melt. So this did not go very well. Very bad soldering, and I think there are some yeah, two of the pins are connected. I'm gonna try and fix that later. Now I'm gonna add this little capacitor here. Okay, let's see if that works. No, that just blew it away. A little less airflow. Yeah, that melted. Turn it around. So it is soldered on, but is it good enough? I'm gonna clean this up now and maybe measure a little bit, see if the connections are okay. I'm just gonna do a little bit of a touch up with my soldering iron, and I'm not pleased how this went, these first components. What I think went wrong is I should have used a little bit more flux. So I think that looks okay. Much better. Alright, the solder paste was just a mess, so I'm gonna try a little bit different strategy now. I'm gonna use my soldering iron and regular solder tin. I'm gonna tin the pads first a little bit. Just a little blob on the pads. That looks good. Alright. So now I'm gonna try and solder in the small resistor and the small capacitors. Add a little more flux. So it doesn't matter if it's not perfect flush with the board. This is just homemade stuff. Okay, I think it is in position now, and I'm gonna try and zoom in a bit, and then let's see if we can solder this. Just gonna hold it down to the board. Well, it already moved, so okay. Thing is, everything becomes so sticky with the flux. I think it got soldered down. Now I'm gonna take the other side. Yeah, I think that's okay. It's not centered on the pads, but I don't mind that. And now this extremely small capacitor, I can hardly see it. It is on, but it's not straight, so try to straighten it a bit. Alright, I think it's on, and in the meantime I also soldered this one, and that went straight in, so yeah, it's on. So this is not going very well. I actually managed to lose the last capacitor and these three capacitors are 100 nanofarads, so I just found this one a little bigger, but it's the same value, I think, and yeah, it's a little bit bigger, but it's not in the way of anything, I think. So now comes the real challenge, these small ICs. And I think I will use the drag soldering technique on these. I don't want to use that paste because I think it was just a mess. It's hard to control the temperature and things like that. So I'm gonna use a little bit of flux and then try to drag solder. And I changed my solder iron tip because it's better to have a larger surface when you do these kinds of drag soldering, because you need to add a bit of solder to the tip. I think that's a good amount, maybe a little too much. So now it is in position. Then I add a little solder to the iron. Problem now is to prevent the chip from sliding away when I apply the solder iron, so I'll try to keep it down. Let's see now. So hopefully I won't burn my finger. So now at least it is soldered on, but some of the pins got bridged. I'll try and fix that first, but first I'm gonna solder on the other side. Okay, some bridges. Need to fix that. A little more flux might help. Using a little bit of solder wick to remove the excess solder on that pin. Alright, so I had to do a couple of things here. I had to desolder the first chip and resolder it again. and I had to take off the large solder tip and instead use my smallest, because I felt that was giving a better result. And then I soldered on the second chip here, and that went pretty well. But the solder blobs I had to remove with this wick, and I think that went okay. Hopefully all the pins are soldered to the pads, but everything is so small I can't hardly see the pins even with my magnifier glasses. And even taking a little chip like this out of the plastic is a little risky business in itself, because you can suddenly break or bend some legs and then you're immediately in trouble. The last chip, I just positioned it and tacked it down in the corner. Now I just add some more flux. And I don't think this flux is the best one. Some old cheap stuff. So maybe I should invest in some good stuff. Okay, let's see now if I drag the solder over. You see there, it just makes a big blob, but that's okay. Now the other side. And then I clean off the tip and try to drag it over like that. But then it's way too much, so I need to remove with the wick. And that was the problem with the big solder tip. It didn't have the precision to do this. Okay, so now the excess solder is gone, and ow. And I think these are okay. Just drag a little bit over each pin, and then I'm gonna measure later that there are no shorts. I have measured all the pins now, and I found a couple that were shorted, but I just applied a little bit more solder and then removed it again, and yeah, now it seems to be okay. Alright, now that the small parts are on, what's remaining are the larger parts, and next I'm gonna solder in the pin headers, and I have just fixed them down to into a socket just to keep them straight. Finally the socket goes in, and it goes right there, and the connector for the Raspberry Pi goes there, and there's a jumper that's gonna go on the back side here. So yeah, this is just plain soldering, not much to show here. Alright, so here I did a mistake. You see this jumper should go in there, but I have already soldered in the socket, so it will be pretty difficult to solder that on from the other side, but I think I can reach in between there. Let's see now, can we do it? Yes, we can. Yeah. Alright, that was all the soldering, and yeah, I think it went well, but it remains to be seen if it works. I actually have my doubts. I would give it a 40% chance of success. Final bit is this jumper, which configures if you have a Super Denise or a Denise chip, and I'm gonna try this in an Amiga with a Denise chip, so it goes in there. Just a little cleaning with some IPA and we are ready to test this. It's time to test, and I found one of my old Amiga 500s, and that's the tiniest chip that we're gonna insert into this RGB2HDMI and insert this one there. Hopefully it will work. I'm not really sure it will because there were some problems with soldering of at least one of the little chips, but I am hoping. If it's not working, then I'm not gonna bother with this anymore. It will go into the trash. Alright, so now it's time to download the RGB2HDMI software, and you find that on GitHub on Hoglet67, and I download the latest release. Scroll down to the bottom and here's the zip file with the necessary files. So I already downloaded it. If you take a look at the zip file, this is the software that you're gonna copy over to the SD card. I formatted the SD card as a FAT32 and copied all the files over to it, and now I have inserted it here, and I took the chip out of the Amiga. Let's see now. Insert it into the RGB2HDMI device. Then the device goes into the socket, and yeah, the pin headers I used are a little thick, so they might be a little bit hard to get into the socket, and they even might damage the socket a little bit, but I try anyway. Yeah, it's a little bit tight fit, but it goes down. With the force you can do lots of things. And now the Raspberry Pi comes on top with the electronics down like this. Contacts facing the keyboard. So let's plug in the HDMI cable, which of course has a little problem already because it can't fit in front of the keyboard, so I have to remove that, but yeah, we'll see. This is just a temporary solution anyway with the cable, and that's it. I'm just gonna power on the machine, and here goes nothing. Hey, amazing, it worked. This was actually a little relief. Maybe not the biggest thing to get working because it isn't that complicated device, but with all the SMD soldering and everything like that, I had real doubts that this would go okay. But take a look at that. That is crystal clear. Pixel perfect. That is amazing. Really nice. So I'm filming the screen, so you won't see the actual picture the same as I do on my LCD TV, but it's really looking good. I'm trying to find a game or something to load. I have actually seen a demonstration of this before, but I haven't actually seen it with my own eyes, and yeah, this works just fine. And now I've zoomed in pretty hard with the camera. You can see the pixels are perfect, almost. Alright, that's it for this video. It was a rather lengthy demonstration on how to build RGB2HDMI, and it worked out great. So hope you enjoyed this video, and please subscribe if you want to see more. I just want to say thanks for watching, and a special thanks to my patrons over at patreon.com. Alright, see you, bye bye.